Right, question 13. Calculate the total area of the shaded shape, leaving your answer in terms of pi. So the rectangle, or the square even at the bottom, is quite straightforward. So the area of here is going to be 8 times 8, which is 64 centimeters squared. Now the semicircle has obviously a diameter of 8, so it has a radius of 4. So the area of the semicircle is pi r squared for the whole circle, and then we're going to divide by 2 because obviously it's a semicircle. So this becomes pi times 4 squared divided by 2. So this becomes 16 pi divided by 2, which is 8 pi. So then add these two together, so we get the whole area is 64 plus 8 pi. They said leave your answer in terms of pi, so we are expected to have a pi in the answer. Anything to the power of 0 is 1. Evaluate given your answer in standard form. So 4.5 divided by 9 is a half, and then with the powers we subtract, so we get times 10 to the power of minus 4. Can't have 0.5 in standard form, so we're going to have to make this 10 times bigger, which means this is 5 times 10, and then we're going to have to make this smaller to the minus 5. Question 14. So again, we have things measured correct to the nearest this, correct to the nearest that, means bounds of measurement is probably going to be needed. So distance travelled 3,000 to the nearest 100, so he could have only gone as far as 2,950, or he could have gone as far as 3,050. Time, it could have been 79.5 hours, or as much as 80.5 hours. Write down the calculation would need to enter to work out the greatest value for the average speed. Well, speed is equal to distance divided by time. If he's going to make the greatest average speed, he's going to have to travel as far as possible, but as quick as possible. So this is the calculation he would have done to find his average speed at its quickest. Part B, Klaus has now bought a new car. So 60 miles took him 2 hours, second journey was X miles, and it took him Y hours. The times are correct, but the journey distances are only to the nearest mile. He wants to calculate the least value for the average speed for these two journeys combined. So the average speed, the least value, so again we're going to be using speed equals distance divided by time. Now the times are correct, so we don't have to worry about the times. The distance, however, are to the nearest mile. So if we're going to go for the least value for the average speed, now because the time is fixed, to make this fraction as small as possible, he's going to have to have travelled the greatest distance again. So he's going to have to travel as far as he can in that period of time, because that means his average speed is going to be slower. So his total distance was 60.5 plus x plus 0.5 miles, because it was x miles plus the extra 0.5, because we're not quite sure about the accuracy. So this comes in his time was 2 hours plus the y, which are measured perfect already. So this comes in 60.5 plus 0.5 is 61, so this is 61 plus x divided by 2 plus y. That's how he would find his least value for the average speed. Okay, similarity question now. So as soon as we see similarity, we need to look at the small object, the large object, and the scale factor. And then we've got length, area, and volume. And we fill in anything we know. So the small volume is 2, and the large volume is 54. We can see then that the volume scale factor must be 27, because 54 divided by 2 is 27. So we can find that the length scale factor is the cube root 27, which is 3, and then just to fill in the blank we'd have 9 for the area scale factor, because 3 squared is 9. So how many of these larger pebbles will need to form a straight row equal in length to 15 smaller pebbles? Well, the smaller pebbles, obviously, if we assume they are 1 each, there is a length of 15. So to find the larger length, now usually we would do the smaller length times by the scale factor, but because each of these larger stones are obviously going to take up a bigger amount of length each, we are going to do 15 divided by the scale factor, which gives us a length of 5. So the larger stones will have a length of 5, so we need 5 stones to fill the gap, because we've got 15 to fill, and the link between the smaller and larger is 3. So for every 5 we would have 1 large stone. Express the following as a decimal. The first one of these is going to be standard form, so we're going to take the decimal point back 2 places, so we're going to get 0.021, and the second is indice rules, anything to the power of minus a half, so that means 1 over 400 to the power of positive a half. This means 1 over the square root of 400, so this is 1 over 20. They want that as a decimal, so we need to say how many times does 20 go into 1. 20 doesn't go into 1, 20 doesn't go into 10 either, so we've got 100, 20 goes into 100 5 times, so the answer is 0.05. Express as a recurring decimal. If you have a fraction, we're just going to use the method for division. 99 doesn't go into 1, 99 doesn't go into 12, 99 into 120 is once, and there are going to be 21 left over. 99 into 210 is twice, and there are going to be, that's going to be 198, so there are going to be 12 left over. 99 into 120 once, 21 left over, and we can see now that this repeat is 12, so it's going to be 1 2 1 2 dot dot dot, so it is 0.12 as a recurring decimal. Thirds, find the value of ABC. So this is root 5 times root 7 times root 70. So we're going to split the root 70 into a 7 and a 10. The two 7's give me the whole number 7, and then we're left with a root 5, and I'm going to split the 10 into a 5 and a 2. These then give me 7 times 5 times 2. So this is 35 lots of root 2. Question 17, proportion. So y is inversely proportional to x, so y equals 1 over x, so k over x. Got some value, so we can say 50 equals k divided by 2, so 50 times 2 equals k, so 100 equals k. Then we're going to replace that in here, so we get y equals 100 divided by x. Now we're going to use that to find these two values down here. So to find this one, we get y equals 100 divided by a half. How many halves go into 100? 200. To find this one up here, we're going to use that 12.5 is equal to 100 divided by x. Swap these over, so we get x equals 100 divided by 12.5. So how many 12.5s go into 100? Well, 2 12.5s are 25, and 4 25s make 100, so it would be 8 12.5s to make 100. Question 18, draw a histogram. So we need to find the frequency densities, so that's done by frequency divided by group width. So 36 divided by 20 is 1.8, divided by 10 23.6, and then half it to get 1.8. 44 divided by 20 is 2.2, 100 divided by 20 is 5, 12 divided by 20 is 0.6, and then be careful here, this is 8 divided by 40, which is 0.2. They give us the time across the bottom, so we need to do the frequency density at the side, so I've got to go up to 5, so I'm going to say 1 2 3 4 5, so between 0 and 20 we go to 1.8, which is there. Between 20 and 40 we go to 2.2, which would be here. Between 40 and 60 we're going to go all the way up to 5. Between 60 and 80 we're down at 0.6. And then between 80 and 120 we are right the way down at 0.2. And then just turn them into bars as opposed to just straight lines going across. And there we have it, the histogram. Question B. 220-year-olds were set an identical task. The time taken to answer the short questionnaire were using the same time intervals as with the 10-year-olds. The median time of the 20-year-olds was 58. Gemma says that the median is the same. Fred disagrees. Explain why either Gemma or Fred could be correct. So we know the median for the 20-year-olds was 58. So we need to know what the median was for the 10-year-olds, really. So we're going to look at our data. They asked 200 people, so the median would be between person 100 and person 102. So there are 36 people in group 1, so then we include the next 44, which takes us up to 80. So then 180, so person 100 and person 101 would be in the group between 40 and 60. So we know that the median is between 40 and 60 for the 10-year-olds. Therefore, Gemma could be correct because 58 is within 40 and 60, but Fred could be correct because actually 58 is close to the edge of this, so the median could be closer to 40, and that is the answer. Question 19. Ralph does not like strawberry flavoured chocolates. In a dark cinema, he selects 2 at random. There are 20 of these chocolates, 5 are strawberry flavoured. Calculate the probability that at least one is strawberry. So we have that he picks strawberry and not a strawberry, or we have he picks not a strawberry and a strawberry, or because it says at least one, he could get strawberry and strawberry again. So probability picks strawberry, 5 of them are strawberry, so this is 5 out of 20. And means times there are 15 not strawberries and there are only 19 left because he's already picked one. Or not strawberry, this time there are 15 out of the full 20 to start with, and 5 out of these 19, or 5 out of the 20 times by 4 out of 19 because he's already picked a strawberry. So 5 15s are 75, and 20 times 19 is 380, plus 5 15s are still 75, and there are still 380, and this one is 20 out of 380, and then 150, 170, so this is 170 over 380, and we could take the zeros off, which gives us 17 out of 38 as the probability that he has at least one strawberry.